Welcome to Rules for Significant Figures. So in science, all of our measurements have some amount of uncertainty associated with them. We're not totally sure about our measurements, and that's not because we are doing something wrong with our techniques or something. It's just that ultimately we're always physically limited by comparisons of some object against some other object, and we're never perfect with those. We can't ever be totally certain that our measurement is exactly right. So we need some way of expressing how much uncertainty there is in our measurement, and then the uncertainty in any calculations that are based on those measurements that we've taken. So the easiest way that we have for expressing uncertainty is using significant figures. This is sometimes abbreviated sig figs, S period F period, or capital S period F period. So we have other methods for expressing uncertainty more accurately than using significant figures, but they're generally requiring a lot more work to use them correctly, at least. And in most first-year chemistry courses, significant figures is good enough. And so once you learn the rules for significant figures, it's generally not too difficult to apply. But these other ways that we have of error propagation, they're generally significantly more complex, and for most, at least first-year chemistry courses, we don't need to use those. When you're recording a measurement or rounding a calculation, first, write all the digits that you're sure of, plus the first digit that you must estimate in the measurement. So the first digit that you must estimate is the first doubtful digit, or the first uncertain digit. So if you have a ruler and you've got graduation lines here and there, whatever those are marked, so let's say those are in the ones place, and you know you've got some object that is this long, you know that it's in between those two measurements, you know that it's longer than this one, if it's coming from the left, and it's shorter than this one. So you know that the ones place is whatever number this one is, and then you know the digit past that, so the tenths place, is something in between. So you estimate. If it's halfway, then it's a 5. If it's 90% of the way, then it's a 9. If it's only 10% of the way, it's a 1, and so on. So you're estimating that first digit past whatever marks you have. So this is the first uncertain digit. It's uncertain because you're guessing. Everybody using that instrument or that measuring device should get the same digits up until the graduation marks. After that point, then it's a guess. And so different people may be getting different values. And that's why there's some uncertainty there. So when we're writing a measurement using sig figs, the last digit is our first uncertain digit. And then we round our measurements to the highest place with doubt, which means we only have one digit that is uncertain. It's just that last one that we're writing. So, suppose you have an analytical balance, and your balance displays mass to the thousandths place, but under the conditions of your experiment, the uncertainty is plus or minus 0.02 grams. That means you can write, if your balance reads 12.432 grams, you can write 12.432 grams plus or minus 0.02 grams. It's important to keep the unit in there, because sometimes we write uncertainty in the absolute units, and sometimes we write it as a relative uncertainty, so something like 2% or 0.02%. So we want to keep the unit there. So this is plus minus notation, and this is recording our uncertainty. So now we know that our value is 12.432 grams plus or minus 0.02 grams. So that 0.2 is in this place where we currently have a 3. So we really know that it's somewhere between 12.452 grams and 12.412 grams. So you can then write this measurement using using significant figures notation as 12.43 grams. And the last place that is written, this 3 here, this one, that is our first uncertain digit, because we're not sure that that 3 is right. We know for sure that the 1 is right here, we know the 2 is right, we know the 4 is right, but that 3 we're not sure is right, because if our value can be anywhere between 12.412 and 12.452, The 2 here is basically meaningless for us. We really know that it's somewhere between 12.41 and 12.45, which means that we don't know that that 3, this value there, is right. We think that it's close, but we're not sure that it's right. Maybe it's 12.44, or 12.45, or 12.42. So that 3 is our uncertain digit there. So when you're adding or subtracting using significant figures, first you add or subtract as you normally would, and then you look through the numbers involved in your calculation, so all the numbers that you're adding and subtracting, for the uncertain digit in the highest place. So the highest place is the highest decimal place. It may be to the left of the decimal, it may be to the right of the decimal. And then the answer's uncertain digit must be in that place, the highest place, which means the place farthest to the left, that decimal farthest to the left that is uncertain in any one of our numbers in our calculation, that's the place to which our answer has to be rounded, and that's the uncertain digit there. So we're rounding our answer to that place. So we can't keep any digits past the first one in our answer here. So here we've got an example, 23.1, 16.01, 1.008. We're adding those up. If we just carry out the number math, if we plug all these into our calculator will tell us 40.118. But we've got uncertainty here in this digit. We've got uncertainty there in that digit. And we've got uncertainty here in this digit. So this one is in the thousandths place. This is in the hundredths place. And this one is in the tenths place. The highest place out of those 3 is the tenths place. So this, the one that was underlined there to start with, that's the place that we need to round our answer to. So 40.1. So again, we can't keep any digits past the 1 in our answer, because we don't know those digits are right. We don't know that this 1 or that 8 is right, because we don't know here what that digit would be. We don't know what the thousandths place digit would be. Here we don't know what the thousandths place digit would be. So maybe this is an 8, or maybe if these aren't zeros, if they're something else, then that value wouldn't be an 8. It would be something else. Or it could be something else at least. So we don't know the hundredths place or the thousandths place. It should not be thousands, it should be thousandths place. In our first number here, the 23.1, and this means that the 1 that we've written in the hundredths place of our answer, this one, assumes that the hundredths place of the 23.1 is a 0, which we don't know. So we can't write any digits past that. So we can also state this rule as, when adding or subtracting, round your answer to the last full column on the right. So if you have a digit in that place for all of your answers, then you can write that one. If you don't have a digit in that place for all of your answers, then you cannot write that digit in your answer, that place in your answer. If you're using a calculator, you need to identify and underline the uncertain digit in the number that has its uncertain digit in the highest place, and then round your calculator answer to that place, like I did on the last slide. When you're multiplying and dividing, we do things a little bit differently than with adding and subtracting. With multiplying and dividing, we need to count how many significant figures exist in each of our measurements. So we count the certain digits and the first uncertain digit. Remember that the first uncertain digit is significant. Any other uncertain digits are not significant. Those are insignificant. For numbers without any zeros, then, the number of sig figs is simply the number of digits that is displayed in the number. So if we have something like 12.35, all 4 of those, the 1, the 2, the 3, and the 5, those all count as significant figures. So if we have something like this, 478,621, all 6 of those digits count, so we have 6 sig figs. If we have 62.27, we have 4 sig figs. For numbers in exponential notation, we look only at the coefficient. We're ignoring the exponential term. So we ignore this times 10 to the minus 6, and we have 6.248. All 4 of those count, so we have 4 sig figs. With 2 times 10 to the 8, the times 10 to the 8 doesn't count. The 2 does, so we have 1 sig fig. When we're multiplying and dividing using significant figures, first, we multiply or divide as normal, just like we did with addition and subtraction. Then, we count the number of sig figs in each of our numbers involved in the multiplication or division, and then our answer can have no more sig figs than the smallest number of sig figs in any number involved in our multiplication or division. And then we round our answer to that number of sig figs. So if we have an example like this, 3.1865 centimeters times 8.8 centimeters, that equals 28.041 square centimeters. But here we have 5 sig figs. So we have 5 sig figs there. And here we have 2 sig figs. The smaller number out of 5 and 2 is 2. So our answer can only have 2 sig figs. So we start counting from the left. So the 2 in 28 and the 8 in 28, and there are our 2. So that's all we can write. And then we round from there. So because our next digit is 0, we round down, so just 28. When we're moving a decimal in exponential notation, do not change the number of sig figs in the coefficient. However many sig figs you have in the coefficient, before you do your moving of the decimal, that's how many sig figs you should have afterward. When you're using significant figures in calculations with multiple steps or parts, the rules for sig figs should be applied at the end of a calculation. You should keep 1 extra digit in each of the intermediate answers in order to minimize rounding errors. So you should underline the last significant digit in each intermediate answer to keep track of where you need to round at the end. So the reason why I suggest doing this is that if you round at every step, you may introduce some significant rounding errors if you have a small number of significant figures at some point in your calculation, and you round, and then you do some calculation on that. Now you're doing a calculation based on the rounded answer, and what you should instead do is basically perform all of your calculations and then round once, only at the end. Just round your answer, round your final answer once when you've finished all your steps. Don't round each intermediate answer. That was rules for significant figures.